In this problem, we want to write the rectangular equation for this parametric equation. So remember, a rectangular equation is in terms of only x and y. So I know what y equals in terms of theta, but if I can figure out theta in terms of x, then I can substitute in. So first, I know I can subtract 2 and then divide by 5. So I know cos theta equals x minus 2 over 5. But I'm trying to figure out what sine theta is in terms of x, so that way I can plug in here. So the quickest way for me to figure this out is to draw a right triangle with theta. So cosine is adjacent over hypotenuse. So adjacent is x minus 2, and my hypotenuse is 5. So if I tried to solve for this side, a squared plus x minus 2 squared equals 5 squared. So a equals the square root of 25 minus x minus 2 squared. Definitely skipped some steps there, so I subtracted and then took the square root. I could also FOIL this out, but I'm going to leave it like this for now. So now that I know all three sides of my triangle, I can find sine, which is opposite over hypotenuse. So y equals 1 plus 2 times sine, which is opposite, over hypotenuse. So I can simplify this problem some more, but I'm just going to go ahead and leave it as 2/5 square root 25 minus x minus 2 squared. So now I have a rectangular equation only in terms of x and y. I also could play around with this some more since I know it's an ellipse. I could play with this. Let's see what I could do. Y minus 1 equals 2/5 square root of 25 minus x minus 1 squared. So then I could square both sides. So what do I have? Y minus 1 squared equals 4 over 25 times 25 minus x minus 1 squared. So then if I distribute that, y minus 1 squared equals 4 minus x minus 1 squared over 25. I can add this, to this side. Y minus 1 squared plus x minus 1 squared over 25 equals 4. So now it's actually in the equation of an ellipse, which is better than what I had above. So when we see it's an ellipse, it should be in the shape or in the format of that conic section equation.